Hey all, Dan here again. I wanted to expand on the video I did just a couple days ago about acoustic radiation, DBSPL. What the heck is DBSPL? I wanted to follow up on that a bit. Got a great question from contractor's point of view. Gary, he had a question about, okay, so I understand kind of how that stuff is. Why does it matter to me? What are these different measurement curves? How loud is too loud? Things like that. So I thought I'd go into it for a couple of minutes, kind of explain a little more about what DBSPL is, these different curves you may have heard, like A weighting, C weighting, things like that. So with the magic of technology, boom, here we are, my wonderful whiteboard. We're used to seeing this thing. So what I've got here is a lot of things. Number one, this is 1.1, acoustic radiation 1.1. So we're actually doing a little extension on top of that. So let's start with the three basic weighting curves you may have heard of. There's A weighting, C weighting, and maybe Z or flat weighting. What we have here is a graph. This is intensity. Higher is louder. More SPL, more dB SPL. This is frequency, so at 20 hertz, really low frequencies, mid bass, mid range, treble, that kind of stuff. So you can think of it sub bass, mid range, treble. So anyway, A weighting is kind of this curve. It's not very, very low. You attenuate a lot of the low frequencies. You attenuate a fair amount of the high frequencies. It kind of mimics the sensitivity of our ear to hearing, what we hear and things like that. And that's kind of what that A weighting means. So it's used more for OSHA requirements of like, well, how loud are things going to be? Let's average up the sound with this kind of a curve on it and see if it's going to damage your hearing. C weighting, on the other hand, is nearly flat, but it rolls off the low and the high a little bit more. It's more for measuring architectural noise, vibration kind of things, stuff like that, where you might be able to perceive it more at a loud volume. So at low volume, low SPLs, this is much more applicable to like how your Fletcher-Munson curves work, how sensitive your ear is. At high SPL, this is closer to how your ear works. Flat is exactly what it is. Sometimes it's called Z weighting, but we just call it flat usually, and that's just flat. There's no weighting at all. So these are just different ways of determining how much attenuation or how much we cut down the level to consider it as equal volume. Now there's these various points here. These are different SPLs. So what do these mean? Gary asks, well, why do I care about this stuff? Why do I care about that? Well, let me just put this into perspective. We know dB SPL is simply a ratio between an upper number and a lower number, and it's expressed in a logarithmic thing, and a factor of 20 means it's 10 times higher kind of a thing, right? That stuff. Factor of 6 dB means it's twice as loud. So jet engine, this is very loud. This is like, being 10 meters away from a jet engine kind of a thing. 120 dB. This is like next to a chainsaw. You're holding a chainsaw in your hand, you're revving it good, get your Husqvarna going, and it's really freaking loud. 100 dB. This is your typical rock concert club kind of scene. Sometimes they'll go closer to 120, but usually they're around 100, 105, that kind of thing. 80 dB, that's a OSHA limit. That's where it says, hey, if you're more than 80 dB of all sound with this filter applied, so we're attenuating some of the lows, we're attenuating some of the highs, and we're adding it all up. If we're more than 80 dB, we're too loud. We run the risk of permanent hearing damage. So that's why you'll see a lot of times 80 dB and OSHA and things like that. And it's using this A weighting curve. If it's a C weighting curve, obviously you can be a lot lower because this one attenuates the highs and attenuates the lows a lot more. So you have a lot more low frequency energy, a lot more high frequency energy put in if I'm using the C weighted. So that's what I want. 60, typical conversation level. You talk to another person. 40, a really quiet library. And below that, it gets down to the point where you just can't hear much. So that's what that matters. So 80 and lower is kind of where you want to live as much as you can, because that's going to keep you from dying. Your ears from dying, I should say. And for me, an audio guy, that is dying. This is, basically a loud concert, chainsaw, jet engine. You want to stay away from these things. You want to wear air protection anytime you're above 80 dB. These curves mean, let's see if I'm calculating 80 dB with flat. I total up all the energy underneath this curve. It can be quite a bit. With A weighting, I total up the energy underneath this curve, and it's not. It takes a lot more energy to reach a higher number because I'm cutting down the SPL a lot, and C is kind of in between. So that's what that all is. That's how that matters. That's why this matters to you, because it tells you how much volume and how much output is going to hurt you. It also shows you that there's just basically, we're talking about pressure and how that works. That's what we're going to be going into the next part of the videos series, and we're going to go into how radiation and piston work. But I hope that adds a little more curve. A weighting is how most of your hearing damage is rated. C weighting really doesn't happen very often. You'll see it sometimes in like measurement specs, but it's really not that important. Z is usually what you see in like measurements of electronics and loudspeakers and things like that. You'll see the Z weighting curve. So typically it's going to be A and Z. A is for OSHA kind of stuff. Z is for scientific measurement stuff. That's what that matters. Way too loud. Way too loud. Very, very loud. Still too loud. Okay, don't go much above that. That's a normal conversation. And of course, then we have, okay, it's quiet library. So there you go. I hope that helps. If you got anybody else have any questions, just shoot them on out. I'll answer them as quick as I can. Thanks, y'all. Periodic Audio, we're happy to help you. Bye.